Hey guys, today we are going to continue our numerical patterns. We are moving on to 15.2 if you are following along in your textbook. During summer vacation, Julie read 45 pages each day. Her brother Brett read 15 pages each day. Complete the tables to show how many pages each of them read after 5 days. What relationship do you notice between the terms in each pattern? So Julie is 45 each day, so the rule for Julie is to add 45. So 45 plus 45 would be 90, so she read 90 on day 2. And then 90 plus 45 is 135, is how much she read on day 3. Might be easier if I just do a text box. Let's try that. All right, so 45 plus 45 is 90. And then 90 plus 45 is 135. And 135 plus 45 is 180. And then 180 plus 45 is 225, is how much she read after 5 days. Now, Brett's rules are different. Brett did not read 45 pages each day. He only read 15 pages each day. So his rule is to add 15, not 45. So on day 2, he read 15 plus 15 is 30. And then on the 3rd day, 45. And then on the 4th day, 60. And on the 5th day, he read 75 pages. So what is the relationship that we can notice between the terms is that Julie is always, so this is not as easy as yesterday's. So Julie started off with day 1 just being 30 pages ahead of him, but every day it increases because she is continuing to read 45 pages each day, while Brett is only reading 15 pages each day. So this relationship is not as simple as saying Julie is always reading X amount of pages more than. It's not an addition relationship, it's a multiplication relationship. So you need to ask yourself, what times 15 gives me 45? And you can figure out, I believe it's 3. Yep. So if you do times 3, let's see if that works. So 15 times 3 is 45, so we know that it works there. Now let's pick any other day. Let's go ahead and pick day 5. Is 75 times 3 225? Let's see. And if it is, then our relationship is that Julie always reads 3 times more than Brett. Yep, and it is. So we've been dealing with addition as the relationship. Now we're dealing with multiplication as the relationship. So Julie reads 3 times more than Brett. All right, let's look at some more examples. All right, so Jack is training for a race. Each week he runs 30 miles and bikes 120 miles. He created a table to record his progress. How many total miles will he run and bike after 5 weeks? Can you identify any relationship between the miles run and the miles biked? So we can see here that the rule for running is to add 30. So we're adding 30 each time. Starts with 30, week 2 is 60, 90, you're adding 30 each time. The rule for biking is to add 20 each week. So 120 each week. So you start with 120, then you go to 240, and then you go on and on and on. So this is going to be another one of those situations because the rules are different. The relationship between them is not going to be an adding relationship because week 1, it is 90 more, but week 2, it's more than 90 more. It's going to be a multiplication relationship. So they have already determined for you that the total number of miles biked is always 4 times the total number of miles run. So my trick to you is to look at the very first one, because those are going to be the smallest numbers, and ask yourself, what times 30 will give me 120? And then you find that it is times 4, then plug it in to the last week and see if it's true. And sure enough, 150 times 4 does give you 600. So that is the rule. It's the total number of miles biked is always 4 times the total number of miles run. So if someone asked you what was the relationship between here, that would be your answer. Moving on. All right, so here is some of your classwork, the first 2 of your classwork. It's using the same data table that we were just looking at with the 30 miles run and the 120 miles per week biked. Number 2 is just asking us to extend this graph. So we have week 5. We want to know what is week 10 and what is week 15. So we can continue and plug in week 6 and 7 and 8 and all of the things, or we can look at the relationship between the total number of miles run each week and what week it is. So 1 times 30 is 30, 2 times 30 is 60, 3 times 30 is 90, so on and so forth. Therefore, we can very easily see what is going to be run at mile 10, because 30 times 10 is 300. And 30 times 15 is 450. And you can do that same trick with the bike as well, because 1 times 120 is 120, 2 times 120 is 240, 3 times 120 is 360, 4 times 120 is 480, and 5 times 120 is 600. So instead of extending this and continuing to add 120, we can just multiply 120 times week 10, which is going to give us 1,200. And then we will find 120 times 15 by using our turtle head method, which will give us 1,800. That is a lot of miles. And that's just a quicker way to find out your distance at a week that's in the future without continuing the graph on week by week by week, which kind of answers number 3. Miguel says that he can use multiplication to find the terms in the pattern. Do you agree? And the answer is yes. You can, and I just showed you how. Now, and we already found the relationship for this data chart. We said that it was always 4 times bigger. So you're dealing with a lot of different things here, you guys. You're dealing with the relationship between the 2 different things, whatever those might be. In this situation, one's running and one's biking. You're dealing with the different rules. You're dealing with the relationship between the 2. So how many more miles run or how many less miles run versus how many miles biked. So this should help you with your classwork today. Let me know if you need any help. I am always here for that. See y'all later.